everything in the universe, from atom to Godzilla galaxy, size comparison. You're about to get smaller than a grain of sand. By the end of this video, your entire life will fit inside a single pixel on the screen. But before we get there, we need to start small. Really small. Smaller than you can possibly imagine. Because to understand how big the universe really is, we first need to understand just how tiny we are. Alright, here's how this works. We're going on a journey through scale, and we're going to do it in powers of 10. Think about it like this. If you're about 6 feet tall, 10 times that is 60 feet. That's about the height of a 6-story building. Now imagine doing that same jump 30, 40, 50 times. We'll start at the smallest thing science has discovered, zoom past you and me, fly through our solar system, leave our galaxy behind, and eventually reach the edge of everything we can possibly see. Let's start where everything begins, the atom. You've heard of atoms, right? They're the building blocks of everything. A single human hair? It's about 1 million atoms wide. But we're not stopping there. Let's go smaller. Inside every atom is a nucleus, the dense core where most of the atom's mass lives. And get this. If an atom were the size of a football stadium, the nucleus would be the size of a marble sitting at the 50-yard line. The rest? Empty space. Almost all of it. Everything around you, everything you think of as solid, is actually 99.999% empty space. But we can go even smaller. Inside that nucleus are protons and neutrons, and inside those, quarks. As far as we know, quarks are fundamental. They can't be broken down any further. And if you're wondering how small a quark is, well, we don't know exactly because we can't measure them directly. Now let's zoom back out, fast, past the nucleus, past the atom, into the world of cells and bacteria. A red blood cell, the tiny disc-shaped cells that carry oxygen through your body, is about 7 micrometers wide. You'd need over 4,000 of them lined up to cross a single millimeter. And viruses? Even smaller. The virus that causes COVID-19 is only about 100 nanometers across. You could fit 10,000 of them on the head of a pin. This is the microscopic world, the hidden universe that exists all around us and inside us, completely invisible to the naked eye. But now let's jump to something more familiar. Us, humans. The average human is about 1.7 meters tall, roughly 5.5 feet. Finally, a scale we can understand, right? Let's zoom out just a little more. Mount Everest, the tallest mountain on Earth, stands at 8,800 meters. That's about 5,000 times taller than you. Seems huge, doesn't it? But Everest is nothing compared to what's coming. Let's go bigger. Earth itself has a diameter of about 12,700 kilometers. If you stood at one side of the planet and tried to walk to the other side in a straight line, cutting right through the core, you'd travel nearly 13,000 kilometers. Of course, you'd burn up instantly in the molten center, but you get the idea. Earth is massive compared to us, but in the cosmic scale, it's a marble. Let me show you. The Moon, Earth's only natural satellite, sits about 384,000 kilometers away. If Earth were the size of a basketball, the Moon would be a tennis ball floating about 7 meters away. And the Sun? If we keep that same scale, the Sun would be a giant sphere 26 meters wide, sitting 2.8 kilometers away. That's the distance of a nice morning jog. But in real terms, the Sun is 149.6 million kilometers from Earth. We call that distance 1 astronomical unit, or AU. It takes light, the fastest thing in the universe, 8 minutes and 20 seconds to travel from the Sun to Earth. 8 minutes. Light can circle the Earth 7.5 times in 1 second, and it still takes 8 minutes to reach us from the Sun. And the Sun? It's enormous. You could fit 1.3 million Earths inside the Sun. But here's the thing. The Sun is actually a pretty average star. It's what we call a yellow dwarf, middle of the road in almost every way. There are stars out there that make the Sun look like a grain of sand. Let's talk about the big boys. Betelgeuse, the red supergiant star in the constellation Orion. You can see it in the night sky, that bright reddish star on Orion's shoulder. Betelgeuse is about 700 times larger in radius than the Sun. If you replace the Sun with Betelgeuse, it would swallow Mercury, Venus, Earth, Mars, and stretch all the way out to Jupiter's orbit. Everything inside that radius? Gone, vaporized. Just the outer atmosphere of a single dying star. But Betelgeuse isn't even close to the biggest. Let me introduce you to Stephenson 218. This thing is a hypergiant, one of the largest known stars in the universe. Its radius is about 2,000 times larger than the Sun. 2,000. If Stephenson 218 replaced our Sun, its surface would extend beyond the orbit of Saturn. Think about that. Saturn, the planet with those beautiful rings, sits 1.4 billion kilometers from the Sun. And this single star would reach that far if you flew a plane around Stephenson 218 at the equator at 500 miles per hour. It would take you over 900 years to complete one lap. 900 years. That's how incomprehensibly large these stars are. And there might be even bigger ones out there. We're not sure. The distances are so vast and the measurements so difficult that we're working with estimates and uncertainties. But one thing is clear, stars can get really, really big. Now let's zoom out again. Way out. Past planets, past stars, past everything in our solar neighborhood. Let's talk about galaxies. Our home galaxy is the Milky Way, a barred spiral galaxy containing somewhere between 100 billion and 400 billion stars. Yes, billion, with a B. The Milky Way is about 100,000 light years across. That means if you traveled at the speed of light, it would take you 100,000 years to cross from one side to the other. And remember, light travels at 300,000 kilometers per second. And it still takes 100,000 years to cross our galaxy. Let that sink in. But the Milky Way isn't alone. It's part of a small group of galaxies called the Local Group, which includes about 80 galaxies in total. The biggest member? Andromeda, our nearest large galactic neighbor, sitting about 2.5 million light-years away. Andromeda is actually on a collision course with the Milky Way. In about 4.5 billion years, the two galaxies will merge into one giant elliptical galaxy. Don't worry though, the distances between stars are so vast that the chances of any actual collisions happening are incredibly small. It'll be more of a slow cosmic dance. And there are galaxies way bigger than the Milky Way. IC 1101. A giant elliptical galaxy is about 6 million light-years across, 60 times wider than the Milky Way. It contains roughly 100 trillion stars. 100 trillion. Our galaxy, with its hundreds of billions of stars, would be a tiny dwarf next to IC 1101. But we're still not done. Galaxies don't just float around randomly. They're organized into groups, clusters, and superclusters. Our local group is part of the Virgo supercluster, which contains about 100 galaxy groups and clusters and spans about 110 million light-years. And the Virgo supercluster, it's just one lobe of an even larger structure called Laniakea, which means immense heaven in Hawaiian. Laniakea contains roughly 100,000 galaxies and is about 520 million light-years across. And here's where it gets truly mind-bending. All of these structures, all of these superclusters are part of something even bigger, the cosmic web. Imagine the universe as a giant three-dimensional spiderweb with long filaments of galaxies stretching across vast voids of empty space. These filaments can be hundreds of millions of light-years long, and the voids between them are almost completely empty. This is the large-scale structure of the universe, the biggest pattern we've ever discovered, and it's all held together by gravity, shaped over billions of years by the invisible pull of dark matter. So how big is it all? The observable universe, the part of the universe we can actually see from Earth, is about 93 billion light-years across. 93 billion. That's the limit of what we can observe because light from farther away hasn't had time to reach us yet. The universe is only about 13.8 billion years old. So light from the most distant objects has been traveling toward us for nearly that entire time. But here's the kicker. The observable universe is probably just a tiny fraction of the whole universe. We don't know how big the entire universe is. It could be infinite. It could be 100 times bigger than what we can see. Or 1,000,000 times. Or more. We just don't know. And honestly, we may never know. let me bring this full circle. Remember that atom we started with? The one that's about a millionth the width of a human hair? The observable universe is about 10 to the power of 35 times bigger than that atom. That's a 1 followed by 35 zeros. And somewhere in the middle of that scale, between the incomprehensibly small and the incomprehensibly large, there's you. A tiny collection of atoms living on a tiny rock, orbiting an average star, in an ordinary galaxy, in one small corner of an unimaginably vast cosmos. Everything you've ever known, every person you've ever met, every place you've ever been, every war ever fought, every book ever written, every song ever sung, it all happened on that tiny pale blue dot. And that dot, it's invisible from just a few billion kilometers away. Zoom out a little more, and Earth disappears completely. We're not just small, we're cosmically insignificant. But here's the beautiful part. We're here, against all odds, in a universe that's mostly empty space, filled with violent stars and crushing gravity and freezing voids. We exist. We're the universe looking back at itself, trying to understand where we came from and where we're going. And that's pretty incredible. So what's next? Well, if stars can get as big as Stephenson 218, what happens when they die? How do these monster suns end their lives, and what do they leave behind? Next episode, we're diving into the most violent events in the universe: supernovas, black holes, and the explosive deaths of giant stars. Trust me, you don't want to miss it. If you made it this far, do me a favor, hit that subscribe button and turn on notifications so you don't miss the next episode. Drop a comment and let me know. Did this video make you feel tiny, or did it make you feel connected to something bigger? I'd love to hear your thoughts. And if you enjoyed this, share it with someone who loves space as much as you do. Thanks for watching, and I'll see you in the next one.